Okay, now I am going to discuss about linear transformer to delta or pi network. Okay, this is my linear transformer. Okay, I am going to convert this linear transformer into delta network or pi network. Okay, so I will consider this. Actually, we have already derived it in the previous topic. Okay, the same thing we need to repeat it. Okay, we have apply KVL at loop 1. We have minus V1, and then what we have? Self-induced voltage, which is j omega L1 I1, and then mutual induced voltage due to the current I2. Okay, I2 is entering the dot, so induced voltage positive will be here and negative will be here, and then induced voltage will be j omega M I2 because it is due to the current I2. And if I check the direction of current I1, it is entering positive and leaving negative of the induced mutual voltage. So I got plus sign here. It obeys the passive sign only, so plus sign j omega M I2 equal to 0. So I am rearranging and writing this equation. I am just taking V1 to the right hand side. Apply KVL at mesh 2. We got minus V2. Okay, because the current I2 entering negative, leaving positive. Okay, plus j omega L2 I2, which is self-induced voltage, and then there is mutual induced voltage due to the current I1. I1 is entering the dot, so the induced voltage positive will be at the dot and negative will be here, and then induced voltage will be j omega M, mutual induced voltage, multiplied by the current I1. Okay, due to the current I1 entering the coil 1, there is an induced voltage at the coil 2. So which one is inducing the voltage? Okay, that current I need to consider. Which current is inducing? That current I need to consider. I1 is inducing the voltage, so I1 is considered here. So j omega M I1. Okay, if I check the direction of the current I2, I2 is entering positive and leaving negative. So we'll get plus j omega M L1 plus j omega M. Okay, this is not L1, this is I1. Okay, j omega M I1, okay, equal to 0. Okay, so I can rearrange this. So I will get j omega M I1 plus j omega L2 I2 equal to V2. Okay, you can just simply modify this. This is not L1, it is I1, it is also I1. Okay, so now I can represent this in the matrix form. Okay, I can represent this in the matrix form. I got j omega L1, j omega M. Okay, so here j omega L1, j omega M, j omega L1, j omega M, and j omega M I1, and then j omega L2 I2. Coefficient of I2 and coefficient of I1 is written here. Okay, I1 I2 equal to V1 V2. Actually, I need to write. I need to get the matrix form for I1 and I2. Okay, so this need to be transferred to the right hand side. So if I take this matrix to the right hand side, it will become inverse of matrix. Okay, it will become inverse of matrix. So we know the formula for inverse of matrix, which is A inverse equal to 1 by modulus of determinant of A into matrix of D minus B minus C A. If A is A, B, C, D, so this need to be written. So this is the mathematical formula. You already know it. Okay. Now what I am going to do is I am going to consider A. In the place of A, we have j omega L1, j omega M, j omega M, and j omega L2. Okay, so I need to find the determinant of that. Okay, so we got this as a determinant. So minus omega square L1 L2 plus omega square M square. Okay, now so j omega L1, j omega M, j omega M, j omega L2 inverse is equal to 1 by determinant of A. So I need to write this, and within bracket, okay, within the matrix we have minus D. Which one is D? The last one is D. So plus D. J omega L2 will come at the top, and minus B. So B is j omega M, so it is minus j omega M. Minus C, it is minus j omega M, and then A. What is A? A is the first one, j omega L1. So that is written. Okay. Now take this value inside. So I will be writing the equation like this. Okay, just pause the video and do the calculation. I am not doing anything much other than mathematics. So these things you can do it on your own, and you will be getting a final equation, final matrix like this. Okay. So if you have any doubts in it, you can just come and meet me and ask. It is simple mathematical calculation, so I am not explaining. Okay, so here this minus omega square L1 L2 plus omega square in m square is taken in, that's all. It will come as a denominator for all. So wherever I can cancel anything, I can cancel, and I consider minus j as 1 by j. Okay, or 1 by j equal to minus j. So those replacement I have done, so that I got a matrix like this in terms of I1, I2. Now this will be compared with the delta or pi network. For that I need to consider a standard delta or pi network. Okay, so the standard delta or pi network is taken. This is pi network or delta network, whatever you can consider, both are same. Okay, the current I1 in the primary side we have V1, LA, LB and LC, and the second side we have current I2 and V2. Okay, so here this I3, I4 and I5 are our assumptions. Okay, I am going to apply nodal analysis. So I3, I4 and I5 are our assumptions. So I can simply assume this is I3 which is going down, I4 going from node 1 to node 2, and I5 is going from node 2 to the reference node, whatever this is considered as a reference node. Okay, apply KCL at node 1. We have I1 entering, so plus I1, I3 leaving, so minus I3, and I4 is also leaving, so minus I4 equal to 0. Apply KCL at node 2. I2 is entering, I4 is entering, so I2 plus I4 minus I5, because I5 is leaving, equal to 0. Okay, now apply Ohm's law. We know that I is equal to V higher minus V lower by Z. Okay, so I3, so V1 is at higher potential and reference potential is 0, so V1 minus 0 by LA. LA can be written as J omega LA, LB can be written as J omega LB, and LC can be written as J omega LC. Okay, so we have V1 by J omega LA, and I4 is from node 1 to node 2, so higher potential at V1 is at higher potential, so V1 minus V2 by J omega LC. Okay, last one is I5 V2 minus 0 by J omega LB. So V2 minus 0 potential, okay, by J omega LB. Okay, now substitute in the equation. I1 equal to I3 plus I4 and I2 equal to minus I4 plus I5. Just simply substitute I1 equal to V1 by J omega LA plus V1 minus V2 by J omega LC, and if I rearrange and write, you get I1 equal to 1 by J omega LA plus 1 by J omega LC, V1 minus V2 by J omega LC. This is the equation I'll get. Okay, similarly I2. So I need to substitute what is I4 and what is I5 in this. Okay, after substituting, I will be getting the second equation like this. Now write these two equations in the matrix form. Okay, so the coefficient of V1 is 1 by J omega LA, 1 by J omega LC. Okay, coefficient of V2 is 1 by J omega LC minus 1 by J omega LC. Okay, and then the second equation, coefficient of V1 is minus 1 by J omega LC, and coefficient of V2 is 1 by J omega LC plus J omega LB, this one. Okay, into V1, V2. Now compare the equation 9 and let us consider this is equation number 5. Equation 5 are compared. So if I can directly equate this coefficient with the position of the matrix, I can directly equate the position of the matrix. If I do that, okay, I'll be getting L2 by J omega into L1 L2 minus M square equal to 1 by J omega LA plus 1 by J omega LC. If I take 1 by J omega outside and cancel each other, I'll get 1 by J LA plus 1 by LC equal to L2 by L1 L2 minus M square. Okay, so let it be as it is, equation number 10. Okay, now I will be comparing this minus 1 by J omega C. So what is in that position? Let us see. We have minus M by J omega L1 L2 minus M square. This is what we have there. So I am going to equate that. So J omega and J omega will get cancelled. Okay, LC is equal to L1 L2 minus M square by M. These two negatives are cancelled. So we got the value for LC. Okay, so this LC value can be substituted here. Okay, so that I can find out what is one LA. Okay, so you can substitute LC in equation number 10 to find what is LA. So if I do that, I will get LA value like this. LA equal to L1 L2 minus M square. Okay, so I'll just show it. Okay, this you can ignore. It is just simply mathematical calculations. Okay, this is LC value. I am substituting this value here in this place. Okay, in the place of LC I am substituting. Okay, so here 1 by LA plus 1 by LC is there. So 1 by LA plus 1 by LC equal to L2 by L1 L2 minus M square. This is the equation written here. Okay, LC is taken to the left hand side. So L2 by L1 L2 minus M square minus 1 by LC equal to 1 by LA. Now substitute what is LC. Okay, substitute what is LC. Okay, while doing the calculation, I will be getting LA equal to L1 L2 minus M square by L2 minus M. Okay, similarly I need to find out what is LB. For finding LB, what I need to do? So I have to equate this with this. This two should be equated. So 1 by j omega LC plus 1 by j omega LB equal to L1 by j omega into L1 L2 minus M square. We'll get 1 by LC plus 1 by LB. I can cancel this 1 by j omega, which is on both sides. Okay, so 1 by LC plus 1 by LB. I can get 1 by LB equal to 1 by LC can be taken to the right hand side and substitute the value of LC. So I will be getting LB equal to L1 L2 minus M square by L1 minus M. Okay, we got all LA, LB and LC. If I know all the three things, I can simply draw the equivalent circuit. Okay, this is my linear transformer to pi R delta. Thank you.